Hi, today we are going to discuss about how distribution is achieved and why we need to use distribution in the database management system. Okay, distribution is actually a technique in database management system to distribute the data into several machines as opposed to one single machine. Well, remember the term distribution and NoSQL often get misunderstood because since NoSQL databases are mostly distributed, people think SQL are not distributed. Okay, it's not the case. Okay, it's wrong actually because distribution is actually a technique to make the cluster more scalable. Okay, it's not about NoSQL or SQL. For that instance, take MySQL. Okay, it's actually an RDBMS, which is SQL database, but still it can be distributed. Okay, so don't get misunderstood between those two terms. Okay, well, what's the need of distribution? Okay, let's check this. Okay, so let's consider a single machine where the entire data is actually being in one single machine in one single disk. Okay, or let's say multiple disks, but it's actually like a single node or instance is actually taking care of entire data. Okay, so what happens is when a client is accessing or doing some CRUD operations like read or write on the database, if the data is keep on increasing, what happens is the use of index will get kind of the updates on index will get complex. Okay, so let's say huge data is there and read or write, especially the write access is being done. Okay, what happens is that when that particular write is actually trying to manipulate the entire index, the operation will get slow because there is a huge data which it has to process, okay, to the index. So when this is slow, the query time gets slow, and when the query time gets slow, the throughput for the request for the response to be sent to the client will also get delayed. And obviously, when the data is increasing, the maintenance of the database will get so much complex. Okay, so this has to be rectified. Okay, so this will be rectified when we use distributed database where the entire DB will be will be partitioned into several data sets, and each and every data set, the VM or instance will be taken care. Okay, VM1, VM2, like that. It will be sharded among these VMs, and each VM will have one particular data set to take care of. Okay, so it's not like the entire data is in one single machine. Okay, so I just want to tell, when a client is requested, uh, there will be a processor. Okay, this processor will try to check which data instance it has to access, whether that, or this, and then it will process the result and then it will be sending. Okay, so if you do this distribution, the query time will obviously be increasing, and if that is done, even the load balancing can be efficiently done such that the load is actually segregated in equal ways. Okay, and obviously once that is done, the throughput also will be more. And there is one more case which I have to tell you. Let's say the data is keep on increasing in this particular non-distributed database. There will at some point it will reach the end of the, or it will exhaust the entire space, and obviously the queries will, in that case also the queries will get slow because there is no available space to execute the queries. It's not about I'm not talking about the RAM and all that stuff, but it's just like since it is increasing, it will actually be a complex task to run the operations. Okay, so once it is exhausted, it has to be moved to a separate machine, and then again it has to be re-indexed and all that stuff will happen. Okay, so it is actually a costly thing. Okay, so that's the reason why it is not a good idea to use a single machine or single node instance for storing the data. When you talk about distributed databases, there are two main concepts which often pop up. Okay, those are linear scalability and high availability. Okay, so when you talk about linear scalability, it is nothing but when you add uh, another node to the existing cluster, the entire data which is actually segregated among all these nodes should be rebalanced and put up into this node as well. Okay, when I say that, it means that let's say there are 10 rows here and 10 rows here, 10 records. What I mean is records in these nodes. You have to make sure that finally, when everything is rebalanced, these five machines should take up 40 records. Okay, so in that way the distribution will happen automatically, and since a new node also joined, there will be linear I mean the horizontal scaling has happened, right? Because you added one more node, and even that resources will also come up to take up much more load. Okay, so when you talk about high availability, it is nothing but, let's say this cluster is down. Okay, I mean, it's not the cluster, sorry, the node is down in the cluster. Okay, but even if the node is down, these 10 records, whatever that are there in this D3, should also be accessible to the client. Okay, so now let's learn more about linear scalability. Okay, so let's say the data is divided. For you to understand linear scalability, first you need to understand what part. The data is distributed, right? When we say distributed, it means that the entire data will be segregated into partitions, or partitions are called shards. Okay, so there is a difference between partition and shard. Okay, first let me talk about how sharding can happen. Okay, so let's consider a data. This data has to be divided in such a way that the user will give some logic, and based on that logic, it has to go to one particular shard. I mean, the request has to go to one particular shard every time. Okay, there are a few techniques which will be used to shard the data. One is hash. The second thing is range-based sharding. Third thing is vertical sharding. And there are some other cases where I'll tell you in a moment. Okay, so when you consider hash based sharding, it is nothing but, let's say you have 10 rows. Okay, like that you have 10 rows. Okay, so what happens is, if you have, let's say, one two three nodes, what you can do is you can just apply modulus. Okay, 10 modulus 3. Okay, so what happens is, every time you do this, the remainder will always be coming up in either 0 1 2. Okay, as 0 1 2. Okay, so based on that, whenever there is a record, whenever a new record is added, or whenever, let's say, you get some ID of a record, and let's say it is 5. Obviously, the ID 5 will always be in only one node. Okay, so when you do this modulus operation, it is like it will always, the PKID will always match one particular node, and hence the data can also be segregated equally. Okay, now let's talk about range-based sharding. Okay, let's consider a database where you have ID, name, and address or contact. Okay, this is actually a user database. Okay, let's say you have users starting and users having Aditya, and you have Pratyusha, and you have Isha. Okay, what happens is, the you can actually apply a logic for range, saying that A to, let's say, L. Okay, and M to, let's say, Z. Okay, so all the names which are following between A to L, which are starting from A to L. I mean, the starting character should be in the range of A to L, will fall under one shard, or let's say all the other words which are starting from M to Z, uh, all the names which are starting from M to Z will fall in another node. This segregation is considered as range-based sharding. Okay. Now let's consider vertical sharding. Okay. As you have seen, there are multiple columns, right? Each and every column can be sharded as well, okay, in the database, okay, and each and every shard can be sent to one particular node, okay. So in that way it will be segregated in, I mean, the load will be segregated in an equal way, okay. Now there is another technique, there are some other techniques where the entire database will have some server which is actually a lookup, okay. What actually it does is this lookup service itself you can actually create based on your own business logic, and every time the client hits the cluster it will first do the lookup server check first, and then it will determine which node it has to reach. It is like a custom application or custom implementation of your own business logic to where it has to reach and all that stuff, okay. Now that we have seen the sharding method, let's take partitions method, okay. Partition method is nothing but it also works like a range based sharding, where let's say you have you have 1 to 1,000 records. Let's what usually we in partition method, what you can do is you can either divide each and the entire data set into 10 nodes, so that each and every node gets 1 to 100, and 101 to 200 in the same way till 1,000, okay. So this is one of the employees which we use for partitioning the data, and this is actually called partitions, okay. Now let's talk about how we achieve high availability, okay. Now that we have seen how the data is partitioned or sharded, let's consider a cluster, okay. Let's say we have 4 nodes, okay. When a client is requesting data, usually for high availability case, the thing is, when a request is landed onto the cluster, some node, without hesitation, it has to work on that particular query and send the response, okay. In order for that to happen, there are several things which you have to remember, okay. When a single node is serving some shard, okay, let's say it is serving some shard where it contains records from 101 to 200, okay. But the problem is, this 101 to 200, it is not existing in any other node, okay. So even though the data is distributed in 4 ways, the problem is 101 to 200 records are actually only in one node, okay. When this node is down, obviously this entire 101 to 200 will not be reachable. So the high availability cannot be maintained, okay. So in order for that to fix, what we actually do is, each and every shard or partition or whatever it is will have to go through something called as replication. Okay, so in replication also there are several techniques which we employ to make sure that the entire system is of high availability. Okay, now let's see how high availability is achieved. Okay, I mean the replication is achieved. How it is achieved, we'll see. Okay, let's say a shard or a partition is there. Okay, what actually happens is, in this in the case of replication, usually when the client is requesting some data, if it is read, we'll just take the query and we'll process it and we'll send, okay. But if it is a write request, what actually happens is, most of the vendors of distributed databases will give you some option to select how many replicas you can provide for each shard or each partition. Okay, so but when you say that, what actually happens is the database automatically create the number of replicas you mentioned, and then when there is a write request that happen, it will try to process the it will try to insert some record in the database, and it will try to for example, this is a record 1, and it will try to replicate over here as well. Okay, this is what will happen. Okay, this is called replication of the data. Okay, but there are some things which you have to remember here. Okay, let's say there are 3 nodes which you have in plane. Okay, when there is a write that happens to this particular shard cluster, what happens is there is a three actually there are 3 techniques on how it can actually happen. Okay, there is called single master technique. Okay, what happens is there will be in these 3 there will be only one single master, and it will take up the write, and till it is writing some, let's say, record 1. Okay, till this write is happening, these two will maintain stale data. Okay, because there is actually some write happening, maybe it can be update of a record as well. So if some record 1 is getting updated here, these two will have old data. Okay, when these two when the write query occurred, obviously what happens is this master will say that these two are not to be read. Okay, so if master says that the write all the read queries which are happening to this will be stopped temporarily. Okay, till the write request is happened, and once the write request is happened here, the write request will be sent to these 2 nodes as well. Okay, once that entire process is done, it will send response, but before sending response it will say that these two are not stale anymore. Okay, so this is to maintain the data integrity. Okay, now in this case there are several methods as well. What we talked about is single master case, and there can be multiple masters as well. Okay, to take up the jobs in a parallel way. Okay, and there are other cases also where there won't be any master also. Okay, all the nodes will take care of writing and reading as well. There is one more technique which you have to observe in replication. Okay, let's say you take 2 nodes, and let's say this is master and this is replica of that master. Okay, this particular record, whatever you're having here, will be replicated over here, right? That replication can happen in 2 ways. One is synchronous, and the other way is asynchronous, where in synchronous case, when a query has entered, the record adding or record updating query has entered here, till the record 1 is actually transferred to the replica storage, the response will not be sent. When the response is not sent, the read request will be in waiting state, because obviously when the read is entered here, if the write is not happened, there is a chance of data corruption or reading of stale data. Okay, so in order to avoid that, usually people will go for synchronous replication. When it comes for asynchronous replication, usually a write request comes here, and this record 1 is put here, and before even it is replicated here, the response will be sent. So usually it depends on how your business logic is implemented. Okay, so for example, let's say you are writing some log events. Okay, and usually what happens is those log events won't be deleted. Okay, so a movement happened at 3:12 p.m. and another movement happened at 3:13 p.m. Okay, another thing happened at 3:13 p.m. Okay, these two events has to be stored in database, but generally when this event is being written here, it doesn't need to wait to replicate, right? Because usually in a client, this data won't get deleted, right? In the client, when it is asking data, when it falls here in the replica, when the read is falling in the replica node, obviously it will see the old data, which doesn't have this 3:12 p.m. event. Okay, but it's fine, right? So in those cases, you can use asynchronous replication. Okay, but usually if any data integrity, there should not be any loss. If you think so, then definitely we should use synchronous replication. There is one very important thing which you have to remember in case of replication. Okay, let's say you have a node and you have many nodes as replicas. Okay, this is the master and it is replicating to three other nodes. Okay, so let's say your replication is write in write intensive. In the case of write intensive tasks, what happens is a data which is actually inserted here, it has to be inserted in all these three as well. Okay, if you are having write intensive task, it will keep on writing the data. I mean, it keep on replicating the data, and the entire cluster rebalancing will keep on happening, whatever it is. So because there are too many nodes to be replicating. Okay, so what happens is all the requests, whatever that are coming, will usually be, because you usually will select synchronous replication, right? In that case, the requests, whatever that are coming, will get delayed. Okay, so you have to be very wary of this. Okay, you have to be cautious in such a way that when you are using write intensive task, you should keep the replicas as bare minimum. Okay, that is one very important thing which you should remember. Okay, if your application is read intensive, then no problem, right? Because the write request won't come. Okay, so whenever a read request comes, it'll just land on one node. Okay, it doesn't even need. There's nothing to replicate there. So that's why for read intensive, you can have as many number of nodes, as many number of replicas, and even if you have for read intensive applications, if you have too many nodes, it will be actually good because the load will be balanced to many nodes and the throughput will be high, which is actually a good thing. But if it is for write intensive, you should not have too many replicas. So to sum it up, we talked about what distribution is, how distribution is used, and two main features of distribution, which is linear scalability and high availability. And I really hope that you understood the basics of how distributed databases will work. Be sure to subscribe to not miss any upcoming videos. Thank you.